All right, are we good?
We are good. Okay, greetings everyone. I'm Bonnie Powell. I'm ESNet's communications lead, and I am filling in for Jason Zarowski today. My colleague Andy Lake will be talking about MetrANOVA's software stack for sharing network telemetry. If you're not familiar with it, well, Andy's probably going to do this, but MetrANOVA is a consortium started in early 2024 by ESnet and GEONT, Indiana University, Internet 2, and the Texas Advanced Computing Center. It stands for Advancing Network Observation, Visualization, and Analysis. Andy, take it away.
Yep, so thanks, Bonnie. Two, just as an FYI, I did put a link to the slides in the Zoom chat. Just there's some links later on if people want to click on those, or I guess if you want to read ahead, there they are. They'll probably get posted as well along with the video. But anyways, yes, so I'm Andy Lake from ESnet, like Bonnie said. So I'm going to talk to you about MetrANOVA. Bonnie kind of gave a good high-level overview of kind of what MetrANOVA is. But what there we go. But I kind of want to talk about specifically kind of what we're doing because I think sometimes people have a tendency to get confused because we've got a lot of a lot of different things going on, but it all kind of boils down to we're working on open source software stack for kind of collecting, storing, and visualizing flow data as well as SNMP and streaming telemetry data. So like if you want to compare it to stuff that's out there already, so like at the enterprise level, like if you're familiar with like Kentic, we're basically kind of building like a free version of that is the rough idea. Or if you're familiar with, other open source-ish type things like Elastaflow is out there and there's like a free version that can, with some limitations before you get into the paid version. We're doing similar things to that would be a good comparison. So we're actually building a software stack. It's not available yet. We're hoping, basically the first half of this year have that out. I'll talk about kind of, some institutions are in the middle of kind of, ESNet being one of them, kind of deploying it to beat on it first before we hand it over to folks. Um, but the idea is we're going to build this thing. It'll, it's R&E based. You kind of saw the list of organizations. So, there's no aspirations to build a startup or anything like that. So, the idea is this will always be free and open source. Um, we also recognize kind of in our community, right, there's a lot of different scales of deployment when you start thinking about flow data and SMP data and streaming telemetry, and different institutions have different, familiarity with deploying these types of things, right? So we really want to build something that'll work at a lot of different scales, right? So if you have a large network who's, pretty savvy at deploying databases and running Kubernetes or whatever, we want to serve them, but also like maybe smaller institutions, we like to say like community college level, right? If we can make it easy enough that they could actually deploy something reasonable, that's kind of the goal. And then another important thing will be pulling in lots of good metadata to help all this, data actually be useful and contextualize it, right? So not just, you know, IP addresses, but what institutions do those represent, or what type of science does that represent, or things like that. And then I think maybe one of the biggest, most interesting things we're looking at is going even beyond just collecting it locally, but how do we share that responsibly between organizations, right? So I think like a good example we like to give is so at ESNet, we have something called the my.es.net portal. You can go there, you can see lots of ESNet traffic. Internet 2 has like the Internet 2 Insight console. You can go there and see lots of Internet 2 traffic. Wouldn't it be cool if on the ESNet portal and on the Insight console, like we could include data from the different institutions, right? And show some things that way, right? Now, it doesn't necessarily mean like all the raw data. It could be highly aggregated, right? And there's lots of good questions there that I'll get into, but that's kind of the basic idea of what we're trying to build. So why are we trying to build that? So I think there's been a lot of kind of observation that we've had. We ran some surveys too early on just to kind of confirm this and get a feel for what people's needs were out there. Is we'd really like to lower the barrier to entry to get a lot of this network measurement data. So if you've been on these calls before, a lot of times I'm talking about perf sonar. So if you're familiar with perf sonar, right, that's another measurement toolkit. And we're doing kind of a specific type of measurement in terms of like active stuff. So we're running like iPerfs and OAMPs. And one nice feature of those types of measurements is it's pretty low hanging fruit in terms of it's not very sensitive data, relatively speaking. There's not like a ton of it in terms of having to worry about storing it and things like that, right? But when you want to go beyond that, when you start thinking about like flow data, for example, a lot of that goes out the window, right? There's customer IPs in there. There tends to be a lot of it when you're thinking about size of storage and things like that. So how can we make it easier to deal with kind of data like that? Is the idea. And then the second piece of that is kind of the sharing aspect that I already alluded to is we get a lot of benefit in things like Persona and the fact that like we can look at other people's measurements or we can measure to other places, right? This kind of end-to-end idea. Can we extend that to these other types of data? Again, doing it responsibly, like with appropriate access, not necessarily just sharing everything, but if we have the right credentials or if is there certain aggregations we can do to kind of open this up and share it more broadly. Um, that's kind of the idea. So we kind of already mentioned this, but basically there's 5 institutions. We've kind of all come together. We're putting dedicated developer resources into kind of building this thing and kind of formulating some of these ideas. So you'll see the list there, right? We've got a couple of the national kind of research backbones in there, and then Indiana Global Knock, who runs a lot of the different networks, and then even a compute center with TAC in there. So all of us kind of have similar background in that we've had to deal with a lot of these issues, and or have developed our own applications. Like if you're familiar with like the NetStage project, a lot of those institutions were involved in that. We've deployed things in-house to handle flow data and SNMP collection and stuff like that, and learned a lot of hard lessons along the way that we kind of want to put together and see if we can package something up. I'll also mention too, if you do want to get involved, there's a good page on our website, metranova.org. There's a link later in here about how to get involved. So there's a few different levels of membership. Like these are kind of the main membership level where there's actually dedicated FTEs, and then you have a seat on an executive committee. But we do have something called an affiliate as well. So if you're interested in getting involved, and that's a little bit more flexible, there's no like hard requirement for dedicated resources. But if you have like certain aspects you're interested in exploring, and want to join some of the meetings and things like that's also an option available. So just kind of want to highlight that before I get too much further. Um, and so, okay, so we kind of identified this issue, right? There's kind of the gap in terms of, getting like good flow data and things like that for a lot of institutions. And the idea is we want to kind of build something to help with that. So these organizations came together. So, okay, how do we actually organize the work? So there's kind of two main work streams going on right now in the MetrANOVA group. The first is actually developing that software stack I talked about. So that's the technical work stream. I actually am leading that effort right now. And I'll talk a lot more in depth about that when we get to that point. The second piece is, essentially the second part of that mission. So David Ripley from IU Global Knock is leading that, and that's the policy sharing aspect. So basically, kind of trying to formulate these ideas, come up with some common terminology and language for talking about how to share this data and how to label it and things like that. I have another link with a QR code later on. We do have a document that we've published on the website and things like that kind of captures some of the ideas and considerations in pretty good depth in terms of kind of policy and data sharing and what we're thinking about and kind of using that as a guiding or as a guide as we develop the software stack and some of the technical pieces. So as far as the technical pieces go, right? So we kind of identified we want to build the stack out. And so a lot of what we've been working on is kind of figuring out what the pieces should look like. And so basically, when you start thinking about collecting this type of data, you need to kind of grab it from like the network devices. That's kind of like the collection piece. You need to do, kind of run it through a data pipeline to bring in the metadata and things like that you need to that you care about, and then you need to store it. And so one of the first things we did was kind of look at the storage end, because as I mentioned earlier, especially when you start looking at flow, uh, there can be a lot of it. Again, there's a lot of knobs you can turn turn in terms of aggregation and things like that. But we need something relatively efficient because again, we want to both small and large scale deployments and things like that. And there's a lot of options out there. So we spent a considerable amount of time kind of evaluating different data stores. And so that's kind of what I'm going to cover first is some of the work we've done there that I think it's pretty interesting. If you were at TechX last month, we presented a lot of this there. So apologize if it's redundant, but I think it's actually useful info and trying to get this out there as much as possible because I think there's actually some good work that's gone into this. There is a document associated with this that again I have a link later on to it that goes like really in depth into all the testing and stuff that we did. So if you're interested, I encourage you to look at that because there's some good stuff in there. But I'll try and summarize it kind of here. So basically, we needed to make this decision about, okay, what data store do we want to use? And so, we kind of basically started off thinking about, okay, what are the requirements? And I should say too, each of the institutions had like considerable experience with kind of multiple different time series databases and things like that, just running them in-house or for different projects and stuff like that. We tried to start from a clean slate, like not biasing any of our past experience on that, right? Because we really wanted to just make the best decision possible in terms of requirements and stuff like that. So, basically we had kind of um, two or maybe three kind of main use cases in terms of like shape of data. So one is we wanted to kind of test data that looked like stats you'd get out of like SNMP when you're getting like interface stats. So that's like the port and host stats that listen there. So that's kind of got the feature that it's relatively low cardinality, right? So meaning kind of in unique series. So like if you're thinking of like interface data, it's like the number of interfaces on your network would be like the cardinality, right? So, again, relatively speaking, that's pretty low. Like on ESnet, that's probably like 20,000 or something interfaces is what we have. Some networks are bigger than that, some are smaller, but relatively low, generally speaking. And then there's like consistent timestamps too of that. So like you're usually polling, let's say every minute or whatever your interval is, it's regular. So you're getting data at regular intervals, which again is significant when you start looking at these data stores because some of them have different strategies that do well in that type of scenario versus other scenarios where maybe it's a little bit more sparse and you can't guarantee every, X number of seconds or whatever, you're going to have data. The second kind of big use case is flow data, which is shaped quite a bit differently, right? So that's extremely high cardinality, right? So that's basically driven by what we call the five tuple. So the source IP address, dest IP address, source port, dest port, and protocol, right? And so there's a lot of different combinations of those. Again, depending on your network, I have some graphs that talk about scale. Um, of those, but you can easily get in the billions, which if you look at data sources, that's actually a pretty important consideration. A lot of them have actually even hard limits that they will document in terms of cardinality when dealing with data, and some of them just kind of fall off a cliff with performance, right? And then the other aspect of flow too is it's not quite as regular, right? Like you don't have control over when people are doing their data transfers. So somebody will start a data transfer, right? That'll show up as a flow record. You might never see that exact combination again, or might show up in an hour, a day. You don't know, right? It's not that nice predictable pattern that you get with like polling or something like that. So those are kind of our two big data sets. The second aspect is we didn't want something proprietary, right? We want something open source. We don't want to like force people to spend money on things. Now, it's fine if there are um, you know paid versions of it, right? If you want paid support, in fact, that's probably a good thing because some institutions prefer that. But that basically was key that it was basically kind of free and open source. Wanted to be able to kind of scale and horizontally scale and things like that to handle different cases. Ideally, we wanted a SQL-like query language. I guess the SQL aspect wasn't necessarily a hard requirement, just a solid query language was kind of ideal. And then fine-grained access control to kind of help reach some of our aspirations with the policy sharing was also a key requirement. So we basically started this off by doing a review of what's out there. Like I said, we had a lot of experience. Um, talking to different people and what they'd used and just kind of looking around and kind of getting the lay of the land. Then we had basically some different sized nodes that we were going to test all of this on so we could see how it worked on different hardware. We had basically a representative set of insert statements for testing kind of like write speed and things like that. And then a representative set of queries for pulling it out that we could also time and see how it performed there. And so basically we're doing all of this kind of in the cloud so we could easily kind of bring stuff up and tear it down and things like that. Um, and we basically have three data sets. So the flow data, which I talked about in depth. And then for the SNMP data, we kind of had two variations of it, one we called the narrow and one we called the wide. The narrow was basically just kind of like a low field count. So like if you're just doing like really basic SNMP, like just grabbing packets in and packets out, essentially something similar to that. And then kind of a wider set where like let's say we were grabbing a lot of sets and or a lot of different stats and then storing them in like lots of columns. How does it do that? Right. And so we weren't trying to necessarily get this perfect because once you kind of get into the nitty gritty and trying to adapt this to multiple different database technologies, there's almost like an infinite number of options in terms of indices and things like that. What we really tried to do was just document what we did, tried to do things that were reasonable, right? And then, like I said, we have a really detailed document that kind of goes over exactly what we did. So people have a kind of a good idea. But I think we came out with something that's pretty useful. Um, so kind of just to zoom in a little bit on kind of individually some of the decisions we made and things like that. So these were the main contenders. So you'll see Elasticsearch was one of them. We've got quite a bit of experience with that at ESnet. That was also used in like the NetSage project. So like IU and TAC had also had some previous experience with that. OpenSearch, which is actually a fork by Amazon of Elasticsearch that is Apache licensed, which if you use PerfSonar, that's the data store that PerfSonar uses these days as well. Partially because when we were doing that migration to the new backend, Elasticsearch had a bunch of weirdness going on with its license at the time. It's actually Apache again, but yeah. So OpenSearch was another alternative we looked at. MongoDB, which again a lot of partners had considerable experience with that. ClickHouse. Which we had a little bit of experience with at ESnet, but not kind of as quite as much as some of the others. And then Timescale, which is essentially like storage engine, and I guess you can think of it as a plugin for PostgreSQL. So uh, pretty well known at the Postgres at least layer. So that was kind of attractive in terms of trying it to work with that. So you may notice like, hey, I have my favorite like InfluxDB, for example. Why isn't that on the list? And so really, largely what was the kind of gating factor was the high cardinality of the flow data. Um, if you kind of just look at like the documentation and stuff like that, there's a lot of them that are just like very clear about what the cardinality limits are. Influx has had cardinality limits for quite a while. They actually, in I think, is it 3.0, the new major version that they did, they actually addressed some of them, but to get to those features, you actually have to go to the paid version. So that was part of the reason, like for example, that one was not included. Um, there might be other good ones out there. There's a lot of good stuff. So, probably at some time in the future, we'll need to do another run at these. But we came up with what we thought was a reasonable set and could actually, had a chance at least of handling what we wanted. And two, just to kind of give an idea of the scale of the cardinality, here's kind of a graph talking, about, different data sets and how big they are. So you'll see like the two that are most relevant to us, like, just looking at like ESnet scale, again, your network could be more or less than this. But if you look at interface data from ESnet or like the router ports here, we've got like 22,000 of those. And if you look at, flow, that's just for 1 month. We're at what, over a billion in terms of unique time series, right? So unique 5 tuples. That's not number of flows. That's just unique time to unique 5 tuples of data, right? So it's quite again just to highlight that that's kind of why the flow is largely the driving factor of the cardinality. Is it's just many orders of magnitude higher than like the other data sets that we worried about. And so I've talked a lot about this, yeah. And so again, I mentioned influx. Some other stuff we looked at, like so Prometheus, for example, it's very clear. Like flow data in particular, it's just not built for that type of cardinality. There is an interesting database that we actually tested it. We actually ran a lot of the tests against it at the end. We just weren't thorough enough to include it in because it couldn't complete a lot of it. Is we also looked at something called Victoria Metrics, which is actually trying to one of its stated goals is to remove some of the cardinality limitations with like Prometheus. But it really just it just couldn't handle. It kind of just timed out. Like it was doing a lot of stuff, so we couldn't complete most of the tests. So we ended up excluding that even from the consideration list, even though we did do some initial testing on it just to see if it would be interesting. Like I said, there's probably a lot of other ones, but that you could look at. But this is kind of how I think we came to a reasonable set, and this was kind of the decision process in that. Um, so okay, so let's look at some of the actual testing results. So we basically had three node sizes that we tested. We called them small, medium, and large. You can kind of see the specs there. So 2, 4, and 16 CPUs, 16, 64, and 256 gigs RAM, and then all of them had essentially dedicated SSDs. I think it was the SSD persistent disk in Google is what they call it. So it's not like their fanciest disk, but it's an SSD. Um, so basically that's what we're working with in terms of hardware. Then in terms of the data set, I mentioned this, but just as a reminder, there was basically narrow, kind of low field count, that medium cardinality, tens of thousands. The lots of fields, same level of cardinality, and then the flow use case, which was low field count because you usually have a lot of metadata, but in terms of actual like metrics, you don't usually have a lot. You usually have like, packets and bits moved. Maybe you'll have like TTL or packet length if your router exports it, but that's about the extent of it. Um, and so we had that, and so we had some data sets that basically ran through all of them. Um, so one interesting observation that we had while doing this, makes sense when you think about it, but I don't know that we expected it right away, was some of the data stores were actually very sensitive to the order that the data was inserted. And so especially the ones that are like very time series centric, um, or if you're using one of the storage engines that they offer that was very like time series focused, is they really wanted the data to come like sequentially, like ordered by time, right? Which a lot of times is fine, especially when you're just like collecting data regularly, right? Because time is passing and you're putting in the data. But like maybe for some bulk import cases, or if you get a big backlog, depending on how you do things, you might be just kind of inserting a bunch of stuff at once. And so that actually became significant. So we did try to like kind of keep everything in a nice order for that, but it was just an interesting um, observation that you could sometimes have pretty significantly different ingest speeds if you inserted things in a slightly different order. Um, so then kind of moving on to like kind of the actual results here of the ingest testing. So this is like testing the writes. Um, you'll kind of see our first results here. So as it says at the bottom, the higher the number, the better in this one. And so you kind of see ClickHouse was the big winner here. So this was the narrow data set. And so one observation too, generally, you'll probably notice with the narrow data set is pretty much everything was reasonable with this. I mean, we're getting multiple hundreds of thousands of inserts per second on all of these. And again, all of these are like a single node as well. I mean, I have hardware specs, so um, all that. So ClickHouse was the kind of the clear winner here. Everything did reasonably well. OpenSearch, I guess, is the one kind of lagging furthest behind, and that'll kind of be a theme. So the wide data set, so this is the one with the same level of cardinality as the last, but a lot more fields, or a lot more columns, or however you want to think about that. See ClickHouse kind of is the beast here as well. OpenSearch is pretty far down the list again. And I think Flow was very similar as well. And I guess don't have a graph for that, but definitely one in the document. And then in terms of also looking at storage size, after everything was ingested, you'll see smaller is better in this graph. So ClickHouse was significantly smaller than the other ones. OpenSearch was significantly higher than the other ones. Um, and so that basically was you know good input to decisions we had to make. So after we'd kind of done this, right? So we did all the ingest status testing, loaded everything up. Um, we made, kind of after observing things, when we were to move on to the query testing, we kind of made a few decisions, right? One was it didn't seem like node size made a, significant difference in terms of like anybody like failing that wouldn't otherwise, right? Like the medium-sized nodes seem to give a good approximation of performance. So just to kind of save ourselves some work and time, We decided for the query side of things, just kind of focus on the medium nodes. For the data sets, again, the narrow data didn't seem, everybody seemed to be able to handle the narrow data pretty well. So we kind of didn't worry as much about that on the query side as well, since, it seemed like pretty much everything could handle it. And then we narrowed the field down a little bit. So we dropped OpenSearch. It basically was lagging way behind everything else in the testing. And like I said, with like Elasticsearch licensing change, and it really kind of lost that advantage as well. This says we dropped MongoDB. That's maybe an oversimplification. We did. We actually ran all the query tests on MongoDB. The problem was it just didn't complete most of the tests, particularly with the flow data and the high cardinality. Just it's again it's kind of got some inherent cardinality limitations, which we thought we might run into, and kind of this testing, essentially proved that out. That it just couldn't keep up. So the graphs I'm going to show don't have those two in it, and that's essentially why. Um, and so read benchmarks, we basically had a representative query set of queries on the wide and flow. And then we had, I think, 4 queries for both the wide and the flow. I don't have all the graphs here, they're all in the document. That did things like, okay, let's say for a flow, I want to find a specific flow, right? So that would be one query. And then we'd have others that would maybe look at kind of a wider, have to scan like a wider range of data, like, okay, for an extended time period, basically summarize all the data into buckets, right? So like what were the top organizations or something like that. And or some were like, essentially give me like a network topology or like the type of query you do to build a map and things like that. So we tried to come up with some, kind of typical queries, but also exercised kind of different features of the database, I guess you could say, or different ways you'd have to query the data just to see how kind of all of them handled that. So a few of the queries are here, and these are like numbered queries, so I don't remember exactly. I think this might be the network topology use case. So basically aggregating traffic by link, or I think is maybe this one. Again, it's very clear in the document. We kind of spell all that out, but this is another case where now smaller is better. So in this particular query, ClickHouse was kind of the clear winner again in terms of read speed. For the second query, again, I don't remember exactly which one this was. You'll see Elasticsearch was actually kind of won this one out, although all of them were relatively close. Um, and then kind of the third one, again, ClickHouse was the winner there with Elasticsearch in second place and timescale in third, and same with the kind of the fourth query with the data. And then I don't have all the flow queries here, but that was basically essentially the pattern, which was on the read side of things, it was kind of mixed between Elastic and ClickHouse, kind of winning out on things with ClickHouse generally, I think, won probably more than Elastic, but Elastic sometimes came out. But write speed and storage size, like ClickHouse, was very much the clear winner of all that stuff. And again, too, this was all with our methodology was we did kind of minimal optimizations. And again, we spell that kind of all out in the document. Like there was not a lot of indexing going on or trying to like, really split up the data or anything like that. Like uh, basically just tried to do a relatively simple, straightforward loading of the data and reading it and things like that. So basically where we landed after all of this was for building out our software stack, we're going to use ClickHouse. Um, and so yeah, so we've been kind of working towards that. I think it's actually been interesting since we presented this at TechX. We've had some good conversations with people. I know there's some others who were actually also looking at Flow and did some similar testing and actually also thought ClickHouse looked pretty attractive for this. So that was actually good to hear. And yeah, I actually talked to a couple institutions at TechX about that. So nice to know that maybe, we're not entirely crazy here. But again, I kind of encourage you all to read this document. There's a QR code there. I shared the slides earlier in the chat too, if you'd prefer to click the link. But I encourage you to look at that for more detail on all the testing we did and stuff like that, because a lot of good work went into it. So that's the data source side of things. So once we kind of had the data source decision in place, that kind of opened the door for us to kind of start looking and working on the rest of the software stack. And so, basically to actually kind of fill out what the different pieces are, that's the diagram over there on the right. So we wanted to basically handle flow data and SNMP and streaming telemetry, like I mentioned before. So on the flow side of things, there's a few different protocols, right, that are common out there in terms of ingesting flow data. So NetFlow and SFlow are the kind of the big two. So there is a software package that's open source called PM Account, which has what NF Account D and SF Account D essentially, which are basically two little software daemons that accept both NetFlow and SFlow respectively, right? And then it can spit it out the other end as JSON or whatever, or write to Kafka or like a message bus and things like that. All these multiple of the institutions had quite a bit of experience with that, and again, like in this effort, we're trying to use as much off-the-shelf open source stuff as possible, right? Don't necessarily want to reinvent the wheel. So this orange box right here, or these orange boxes right here, that's what those are, right? So in the case of Flow, these are the things that are actually accepting the NetFlow or SFlow packets from the router. Then we put that on a message bus called Kafka um, before passing it to kind of the one bit of code that we actually do develop, which is kind of the pipeline that takes all of the data, kind of gets it ready for ClickHouse. It sucks in kind of external metadata and things like that, like geolocation information or whatever, before writing it to ClickHouse. So like a couple common questions we get here is like, okay, so why do you have Kafka in the middle, right? You could in theory just go directly to the pipeline. So the reason we found it useful to have a message bus around is a couple reasons. One is it actually makes scaling things out, particularly at the pipeline layer, a lot easier, right? Like all these things kind of get dumped onto the Kafka queues, and the pipeline we can change the number of workers pretty easily and have the workload distributed out um, kind of automatically when you kind of have that Kafka bus in the middle. Another like, a nice feature too is if like the pipeline or whatever goes down, it is kind of like a built-in queue. Now, of course, there's what if Kafka goes down, which these actually queue stuff up as well until Kafka comes up. But that can be nice if you have pieces that kind of go out in the middle. And um, the other piece too, I guess, for the SNP and streaming telemetry side, where we're using kind of Telegraph for kind of pulling of SNP and for gathering the streaming telemetry pieces, and basically it's a similar process, right? Message bus, kind of run it through the pipeline, dump it into ClickHouse, right? And then the idea is to once it's in ClickHouse, we'll have Grafana sitting on top of that. So we'll have some pre-built dashboards for common use cases, and then people have the ability to kind of build their own. Um, I see there's a question in chat, so I'm just going to quickly look at that. So James is asking, has it been fleshed out whether to do stuff like BGP lookups, uh, and like SMP IF index resolution at the kind of this layer with NF account D and SF account D, or is it better in the MetrANOVA pipeline? So that's a great question. So the BGP lookups, the way we're doing it now, you're correct. You could probably do both of those either place. The BGP lookups, just because it's pretty good at it in PM account, so NF account D and SF account D, we're looking at doing that there. And then the interface stuff we're actually doing at the pipeline layer, just because it's a little bit easier. That's one area where it's going to be kind of network dependent, right? Of how they want to import that. Like, so since we kind of control the pipeline fully, like we have ways, if you can even just generate like a YAML file with your interfaces, we can kind of pull that in. Or also there's the option to kind of automatically discover that from like
Yeah.
SNMP collection
That
as well.
that
So
that's the way I was leaning as well. I think it makes sense. I've actually also we have a pipeline that's a little similar to that. It doesn't involve ClickHouse, but just for processing flow data. And honestly, like the metadata, I'd almost consider feeding that into Kafka as a way to easily get it into the pipeline processing because you can have you could have each individual processing pipeline, like if there's parallel, just listen to that for metadata updates, depending on what it is. Like I was considering doing that for like SNMP if index, but again, that's implementation detail.
yeah, and actually too, I mean, it's worth noting like the way we import all the metadata, those are all actually pipelines themselves, right? And so
Yeah.
like, yes, you're totally right. Like one way you can input stuff is like pointed at Kafka and have whatever loaded onto Kafka.
Yep.
I mentioned like YAML files, like we're just trying to have some low-hanging fruit in there. Like, if somebody wants
Mhm.
to easily write a script that talks to whatever system and dumps some
Yeah.
metadata in the YAML and then has us load it in, like, that's an option
Yeah.
or anything in between, right? So yeah, no, that totally makes sense what you're saying.
Yep.
Um,
So thanks for letting me distract you for a minute.
it's okay. Yeah. And I know Bonnie's telling me I should wait to the end, but I always like being interrupted and doing this. A little bit on the fly. If we
You're in
got against the
charge.
wall.
You're in
So
charge.
yeah,
Don't worry
that's
about it.
always
If that's what
dangerous
you want to
too.
do, go for it.
Yeah. Okay, and I'll hit the next one too, just because it's all relevant. So there's a question too for what kind of metadata is being considered and can they be from compute storage logs? Yeah, totally. So like right now we have a couple different kind of metadata pipelines that we import. So like for flow, we've got a standard set of like IP, I guess I'll call it geolocation stuff from places like MaxMind. If you're familiar with like the science registry, we've got basically data from there. So like based on the IP range, there's some stuff about like the project it's involved in and the science discipline and things like that. There's other good sources that we're ingesting from like the LHC. They've got their CRIC database, which also has like specific project information for the LHC that we've imported in. I'm going to show an SC example where like in that, so supercomputing, right, where there's booths all over the show floor, we've ingested booth numbers and things like that. We've got a pretty flexible system for importing stuff. So we've got some built-in pipelines for some of the standard stuff I just mentioned. So stuff for like compute and storage logs, like, yeah, totally. Um, you know, again, it's just a matter of writing some code. The idea is though, like we've got a flexible enough model that you could import that type of stuff. And if you're able to like link it to like flow data somehow, you can do that. I guess also if you're thinking of it as a different data set and entirely, not even just metadata, you could also, kind of import it that way. So yeah, the big goal of this is to kind of be flexible with the type of metadata. Because yeah, depending on the project or the context or whatever, yeah, it's very valuable to be able to do, import different things. So um and yeah, and I can talk more about that at the end if people have more specific questions on that. So yeah, so I just kind of had mentioned supercomputing. We basically actually have a bunch of working code that we've been building out. So supercomputing in November was always kind of a nice place with SciNet being built. To kind of test stuff like this out. So we actually deployed kind of the MetrANOVA kind of the flow side of things, the collectors that I mentioned, and the pipeline and ClickHouse and all that at SciNet. So we were able to import both NetFlow and SFlow data from the devices there. And then we did have like some custom metadata for like the booth numbers that we were able to pull out of sources like Nautobot, which they had running there. Tag that in ClickHouse and then build some Grafana dashboards. So you'll see this map here. So basically what that map is, that shape is what the show floor looked like. So down here was the stadium and then this was the main show floor for those of you that were there. And then the purple squares are basically, basically being lit up based on the amount of traffic that was coming out of them at the time the screenshot was taken. So yeah, so that was pretty cool that we were able to kind of prove out that a lot of this stuff can work, and yeah, sign up was kind of a great opportunity to really bang on this stuff. Um, this is kind of the specific set of stuff that was running at SciNet. So basically, I had flow data coming into NF account D. We also had the SF account D. I guess that's not drawn. Going into Kafka, then going through our MetrANOVA pipeline. So the standard metadata is the stuff I described earlier, like the MaxMind stuff, science registry stuff, things like that. The custom metadata was the booth stuff that I mentioned as well. Things like that coming out of Nautobot specific to SC. That went into ClickHouse and then into kind of the Grafana map, that I just showed. We use something called Terra Nova, which is I think just about open source that we developed at ESnet. That's for basically a map editor for actually drawing out maps, both logical and kind of geographical maps like that. And then you can export it as like Grafana plugins and different things. So it was actually kind of a cool thing to or a cool use case to build up, use it for that. So yeah, so these were kind of all the pieces required to make all that happen. Um, Yeah, SE was in November. We talked a lot about this at TechX in December. Kind of our goal, from here on out is to really kind of clean up the software and kind of get it ready for release. So we're hoping to have a beta version out kind of first half of this year. The idea is we'll be distributing this as a set of Docker containers and a set of Kubernetes Helm charts. So the idea there being, containers are kind of a nice way to package all this stuff up. Um, we don't want Kubernetes to be a requirement for people because we know different organizations, are at different stages of using Kubernetes or not. And if you don't use Kubernetes now, it's probably a pretty big barrier to cross if you're not already kind of familiar with it. So we didn't want that to kind of limit people. So the idea is like we'll have some Docker Compose images to kind of bring these pieces up, some guidance on like the hardware and things like that you'll need to do in that setup. But also for people who do have Kubernetes running, like at ESnet, we do a lot of stuff with Kubernetes, IU does, things like that. We do have some Helm charts that we're using. If you look at our GitHub repo, you can probably pretty easily find we got a Helm repo set up in, in one of them that we're kind of building stuff in. So we'll have that as an option too. And then a lot of this is going to be putting together guides and workshops and things like that. So we're trying to put all that stuff together now, before we release this to the world. But yeah, so not quite there yet, but coming soon. And I guess before I get into the next last piece, I should say too, IU is currently working on deploying this kind of in production. Specifically on the SMP side first is where they're focusing because they want to get rid of some legacy things. And then on ESnet, we are also doing the same thing. We're trying to kind of migrate our existing flow system over to all of this. I was actually like literally working on that right before this talk. So we're hoping to have that soon, and that's kind of our next stage and really beating on this and hoping to get this ready for a wider audience. So then kind of the last piece I want to talk about real quick is the policy sharing aspect of it, because I spent a lot of time on the tech stuff. But there's a lot of been good work that's been going on the policy side, and I think again a lot of the interesting stuff once we get going will probably come out on this side too, right? So basically when you're talking about flow data and things like that, right? It's relatively sensitive data, right? And so a lot of the data sets have different sensitivities. So perf sonar, as I mentioned earlier, not particularly sensitive. Flow though, you got customer IP addresses and personally identifiable information and things like that you have to start worrying about, right? So each organization is going to have different levels of comfort, and they also get too depending on the traffic and where it's going and heading and coming from and things like that. There's going to be different policies that we need to apply to it. So we need a way to kind of set expectations and kind of talk about those things. So we've been looking at something called the traffic light protocol. We didn't invent this. It's kind of a standard that's out there. Some of you may be familiar with it, which kind of defines like a nice, easy to understand, predefined way to talk about like the different levels of sensitivity of data, right? So basically you have like a level, that's the clear, green, amber, red thing there, and then like a scope, particularly once you get beyond clear, like, what community can see this or what types of users can see this, right? And then we've got to kind of figure out how to actually enforce those, but that's kind of what we're working through right now. Just to kind of go through each of these, clear is the idea where the data is completely public um, data, and this is like perf sonar measurements. Green is slightly more restrictive in that you need to log in, but maybe like a pretty broad community can access it, like maybe all of ARNI, right? So there might be certain types of aggregate flow data or interface data that fall kind of under this category. Then amber, right? This is kind of where things really start to get interesting. There's a lot more lockdown. And sorry if there's any background noise. And so basically this would be like your edge flow data with full IP. So like thinking of like the ESnet context, um, it might be the case that like a certain lab's traffic, whatever, if they log in, they can see any traffic that goes to and from their lab, or maybe like the LAC collaboration, anything on the LAC1 VPN can handle it. And then red is basically the case where you can't export it, right? A lot of us have three-letter organizations that are on our networks, right, and just never can share that data, right? So tagging that so it's not exported is good. And so then kind of here's a document on the policy stuff. and that you can kind of read and kind of covers a lot of these ideas a lot more in depth. And so that kind of brings me to the end. So just to kind of recap, we're working on some of these deployments now, and then hoping later this year to have it. And then, yeah, working on documentation guides. And hopefully we have some workshops later this year as well to actually show how to use this. And that's it. So yeah, here's a link to our website. We also have a mailing list started. It's not really sending anything out, but we're planning to send updates there. It's a Google group. So if you click in the presentation, it'll take you to that Google group. And there's like a join button on there. It'll probably say you don't have permission, and then there's like a join button. You click on that, and then you can get added to the list. And that's it. So any other questions? And thank you, Bonnie, for sharing some stuff. Let me see. I'm going back. John Graham, I missed one of your questions. Are you including HSFlowD as an SFlow provider for Kubernetes deployments? No, we're not currently. We're just kind of focused on PM account and getting from the rows. I'm not particularly familiar with HSFlowD. Is that something specific to Kubernetes, or is that just another SFlow collector?
It can run on any host, Docker container deployed. The nice thing about if it is in a Kubernetes environment, the host looks like a switch, and all the namespaces, services look like sources. And so you get atomic resolution on the flow data by namespace.
Yeah.
So
So
multi-domain stuff you can tweeze out really quickly.
yeah. So basically, is it just an SFlow exporter? Basically, is
This
that
HS flow data, it also acts as an ingress point.
okay?
So on the National Research Platform, this runs on every host, and every host can be an ingress for any other NetFlow or SFlow data source. So local top of rack switches can send their SFlow or NetFlow feeds directly to the host, and then it gets sucked into the Inmon traffic sentinel stack, or you guys could push it into your Kafka.
Yeah, I mean, if it comes out as SFlow, we can collect it
Yeah.
now. If it doesn't, we could, probably write an input without too much trouble. But yeah, it sounds interesting. Probably have to look at that more.
Yeah, it's extremely powerful. I use it quite well constantly actually.
Cool. See, I don't think did I miss any other questions? Any other questions people have?
Going once. All right, well, I'm going to stop the recording.
All right, and I'll stop sharing. So yeah, thank you everybody for listening.